Good morning, everyone. In this video, we are on page 4 in the notes, and this is where we are going to put it all together, seeing what we have done so far with function notation, with inputs and outputs, and also domain and range. So looking at this first problem, we want to find f of -2 looking from this graph. Now, if I want to find f of -2, remember f of x is the same as y. So essentially, I am looking for a y value when my input, or my x, is -2. So if I look on my graph, we want to look at my x-axis and say, if I plug in -2, what y value am I getting on my function? Well, plugging in -2 will give me a y value of +1, but plugging in -2 as an input will also give me an output of -1. So f of -2 can be equal to -1, or f of -2 can be equal to +1. So that's a little strange that we're getting two outputs for that one input. So something to keep in mind as we answer this question. So what about f of 3? If I plug 3 into my function, 3 as an input would be 3 on my x-axis. So if I plug 3 in, we map to this point on my function, which is an open dot, and this point also on my function, which is an open dot. Now, we had said on the previous page, when we tested whether this was a function or not, that if I put a vertical line here, the open dot doesn't count and my function isn't actually defined there. So here where I have two open dots, my function is not actually defined at those points. So what do we say about f of 3? It does not exist, which we're going to abbreviate from here on out as DNE. Does not exist. Now, it doesn't mean the same thing as no solution. It doesn't mean the same thing as an imaginary solution. It just means it's not defined there. So similar to what we did on the first page with this function, we could also say that at 0, the function does not exist because it is undefined. So undefined and does not exist are similar. So let's go ahead and take a look at the third item. It says, what is x when f of x equals 1? Folks, I would put a star by this one because this is usually the problem that throws people off, because we are given the y value. F of x equals 1 is the same thing as y equals 1, and we are looking for our x value that gives us that output. So when we were looking for outputs that gave us those inputs, we traced along the x-axis. Since we are given the output, we are going to trace along our y-axis. There's +1. And where does that y value of +1 map to on my function? It maps to here. So 1 as a y value maps to that point on my function, and the input that gives me that point is -2. So x equals -2. So it's a little bit weird because we trace from the y-axis, find where we're mapped on the function, and then we find the x value that gives us that output. Now, the next question, is this relation a function? And if we look at our graph, we see, it fails the vertical line test. It's hitting at two different spots there. So again, if we think of like an equation, it'd be like I plug in -2 and get -1, and then plug in -2 again an hour later and get +1. So remember, equation is not synonymous with function, but it's kind of good to keep in mind on why that definition makes sense and why that wouldn't be a working function relationship. So this would be a no. And we'll go ahead and put the reason that it fails the VLT. All right, folks, next up we've got the domain and range. So this is where we're going to get some practice with using that interval notation. Now, if we were doing it the old way, looking at my x-axis, we would see our starting value is -3, and we're covered for values greater than or equal to that, but then they stop at +3, and that is not included. So greater than or equal to -3 and less than positive 3. To do interval notation, we're going to read from left to right, and our starting value is negative 3. Because 3 is included, we're going to use a bracket. So then we're covered, we're covered, we're covered. All those x values are defined on my function, but at 3, we have an open dot where the function does not exist, so our domain stops at 3 with a parenthesis, since the open dot means that 3 is not included. Congratulations, we have just done our first interval notation with our domain. Next, the range. Now the range we read from bottom to top, or negative to positive. So starting at our most negative y value on our y-axis, the first negative y value that we get is this. So that's where our function starts. And we'll just guess and say that that's about negative 2.4-ish. Now, does my function, or is my function actually defined there? No. So because we're starting at negative 2.4, the point, but it's an open dot and isn't actually included, we use a parenthesis there as the start of our interval. So we start slightly above that negative 2.4. We're covered going up the axis, all of our y values mapped to something on the function. And then the last y value that we get is this one. And we'll say that that's about at positive 2.4. Now, because it is not included, because we have an open dot there, we also use a parenthesis. So left to right for our domain, bottom to top for our range, bracket if the number is included, and parenthesis if it is not included. So folks, what I would like you to do is pause the video and try the next problem on your own and unpause it when you are ready to check your answers. All right, folks, on this one, if we want to find f of negative 1, we're going to plug in negative 1 for x. So negative 1 on my x-axis maps to negative 1 on my function. So I only get one output for that input, unlike that top one, where we had two different outputs, which made it not a function. Moving on to f of 4. If I plug in an input of 4, we map up to this open dot on my function. So if you're like, why do we even have that open dot there if the function isn't defined there? It's to show that my function is defined for everything up to 3.999999 for an input, but as soon as we hit 4, it is undefined. And as we start getting into the algebra side of these functions, you'll begin to see why that open dot is a stopping point, though it's not defined there. So at 4, we can say DNE for does not exist. Moving on to the next one. What is x when f of x equals negative 2? So we're given our y value. Y is negative 2. Again, I would star by this problem. So we look on our y-axis. We find negative 2. We see where that maps to our function. And it's kind of tough to tell, but this arrow, we can say it's going to keep going and going and going. So we'll just say that for that y value of negative 2, we map to that point on our function, and the input that gives us that y value then would be negative 4. If going backwards like that confuses you, just go in reverse and check your answer. If I plug in negative 4, boop, on our function, that maps to that y value of negative 2. So it's in reverse, but it should work the same in the other direction. The next one, is the relation a function? This is going to be a yes. And our reason for it is it passes the VLT. So it doesn't matter where we put that vertical line, it will always only hit the function once. And if we put our vertical line here, it's not technically hitting the function at all. So yes, it is a function. The domain and the range. All right, folks. So our domain, we read from left to right. Now this graph has an arrow, so it just keeps going, 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 going. So when we're looking at our domain and saying, where is my interval starting on the left side, it's starting at negative infinity. Now with infinities, do we use a bracket or a parenthesis? always a parenthesis because negative infinity isn't a definite value. So we use a soft parenthesis there. Now, moving left to right, where does our interval end? We're covered. All of those x values map to something on my function, but our graph stops at 4. Now, are we actually defined at 4? Nope. So we use a 4, that's where our function stops, but because the 4 itself isn't included, we use a parenthesis. Now for our range, we look at our y-axis, and reading from the bottom up, that's really important. It'd be easier if we could just start and go down, but we start from the bottom, and this part of my graph, it's just gonna slowly keep going down. So where does this interval start? Because it keeps going down, it starts at negative infinity with a parenthesis. Where does the interval end? Well, as we move up the y-axis, it's covered. All of those y values map to something on our graph. And where do our y values stop? At this point with a y value of 2. Bracket or parenthesis, a parenthesis because it's an open dot and that value is not included. So folks, that gives you some practice with some of those new definitions and ways of expressing domain and range. On the next page, we'll get into some more practice with function notation, and you will need your graphing calculators.